In this video, we will be explaining how do computers manage processors. This is a video by Haojun, Juve, and Chunan from DISM 1A01. We will be covering the following: what is a process state, process affinity, process scheduling, algorithms used in process scheduling. We will be comparing algorithms. First off, what is a process? It is defined as a job or a task that is executed by a program. One program may contain many of such processes. How do processes work? As a process runs, it will go through several states. When a program is started, a process will be in a created state. When the initialization is complete, it will be in the ready state, awaiting instruction from the program. When it gets instructions, it will be in a running state, executing the said instruction. Should it require any additional resources, it will goes into the waiting state until it obtains the necessary resources. It is then terminated when it finishes executing its instructions. In a multiprocessor system, it is possible for the operating system to main a process affinity for a given process, which is the value that is used to indicate the preference for a particular process to be run in a specific processor whenever possible. A processor will be dedicated to a job or a set of jobs.
Process scheduling. When multiple processes are in the ready state, which process should be the first to run? This decision is made by the short-term scheduler, which is a module in the OS. A short-term scheduler is used between the ready and run states, but on the flip side, a long-term scheduler is used between the created and ready state. The algorithms used in process scheduling include first come first serve, round robin, shortest job first, and shortest remaining time first. Preemption. Before we begin, what is preemption? Preemption refers to the taking away and restricting access to resources for a process. The first come first serve algorithm is as the name implies. The first process to enter the ready state will be run first, followed by the next one to be ready. The following example shows how it works. Process 1, being the first one to be ready, is run first, followed by process 2, and so on and so forth. The average waiting time for each process, in this case, will be 9 units of time. The round-robin algorithm is a variation of the first-come first-served algorithm, but with the implementation of preemption. It is deemed as the fairest algorithm as each process is allowed an equal amount of time in the processor. The first process to be ready goes first, and after a set quantum time, 3 units of time in this example, the processor runs the next process, and the first process is paused. This is repeated until all processes are completed. The average waiting time for each process is 10.4 units of time.
So next, I'll be covering what is shortest job first and shortest remaining time first. Shortest job first is also known as shortest runtime first, uses non-preemptive, and shortest remaining time first uses preemptive. Both are different algorithms that are based on completing the shortest job first. This is typically effective in most situations, if not most of the time. For shortest job first, much like first come first serve as its name implies, the process that requires the least processor is run first, followed by the next. In this example, we're able to show you based from P1 to P5 and its time taken. First off, the P4 will run first because it's 1 unit's time, which is the shortest time taken to complete the job. Then P3 is the next shortest time to be run, followed by P1, which is 5 units time, P2, 6 units time, lastly P5, 8 units time. Total average waiting time will be 5.8 units time, as shown below. Shortest remaining time, on the other hand, is sort of like shortest job first, except it is ongoing per se. In other words, if more processes are added while processes are being run, and the new processes have a shorter runtime, those will run first. For example, on the chart, P1 arrives on 0 time and needed 5 units of time to complete the job. When the arrival time 1, P2 starts process. Even so, P1 had already started 1 unit of time, which means P1 runs 1 time, which is now left when it is in arrival time 1 will be 4 units time, and P2 will be 6 units time. Since P1 is the shortest job first, P1 will run for the next, except for P2 due to the long units of time needed. Arrival time 2, P1 had already run another time, which is left with 3 units time, and P2 with 6, which remains the same, and now P3 came in with 3 units of time. For now, P1 and P3 have the same unit of time, so who will run first? It will be the P1 who run first, because it is the first process. At arrival time 3, P4 came in with 1 unit of time, and P1 have already run another 1 unit of time, which left 2 units time, P2 with 6 units time, and P3 with 3 units time. In this time, P4 will run first, because P1 is the shortest amount of time than P1. So at arrival time 4, P5 came in with 8 units of time, and it added into the queue. For now, P1 is 2 units of time, which is the shortest, it will run first, and there's no others arrival time at all. So the next process will have 2 units of time being run, then P3, which is 2 units of time, the shortest time, and P2, 6 units of time will be run, and 8 units of time, which is the last unit of time that will be run to finish the process. For this example, the waiting time varies as it depends on the process that are added into the queue. Multi-level feedback queues. Previous algorithm uses a single queue, but with multi-level feedback queues, it can have multiple queues working at the same time. It need not need to be the same algorithm in the queue. It can be different. Why use multi-level feedback queues? It is a common use in modern process, and it has a faster response time compared to the others, and able to have better quantum time. This can have more work being done efficiently. Between the 5, how do we determine which one is the best and most effective? There are 5 ways of comparing algorithms: throughput, average turnaround time, average response time, CPU utilization, and average waiting time. Throughput refers to the number of jobs run in a set amount of time. The more jobs run, the more efficient it is. The average turnaround time refers to the amount of time taken to run a process. The shorter the time, the higher the throughput. Calculation will be completion time minus arrival time. Average response time, on the other hand, refers to the amount of time the process takes from creation to completion. Short completion time is a good indicator of efficiency. CPU utilization is the amount of time the CPU is running real jobs than idling. Finally, average waiting time is the amount of time the process waits to be run from ready state. Again, the shorter the time, the better. Calculation will be turnaround time minus execution time. To recap what we have gone through in this video. What is process? Process state, process affinity, process scheduling. The algorithm used in process scheduling: first come first serve non-preemptive, round robin first come first serve with preemptive, shortest job first non-preemptive, shortest remaining time first preemptive. And how algorithms is measured: throughput, average turnaround time, average response time, CPU utilization, and average waiting time. Thank you for your time. Hope this video has given you better understanding how computers manage processes.